All right. Today's lesson is going to be on non-linear inequalities. So let's first talk about the mathematical terms. Let's start with linear. If a function is linear, then what do we expect in regards to the graph?
It's a line.
That's a line. Okay, good. If we don't have the graph, and I give you a bunch of functions, and I say which of these functions are linear. Let's say you're not allowed to graph. I just want you to recognize which of the given functions are linear. So what do you look for?
The degree.
The degree, correct. So it will be linear if the degree is what?
One.
1. So at most 1. Okay, so you look at the function or the equation or the inequality, and then you determine if it's linear by looking at the greatest exponent. If the greatest exponent is 1 of the variable x, then we say it's linear. We learned in the past on how to solve linear inequalities, but today it's going to be non-linear. So for an inequality to be non-linear, that means the degree, or the greatest degree, has to be what? Or the smallest degree has to be what?
Bigger than 1.
It has to be greater than 1. So anything above 1. So it could be 2, could be 3, could be 4, and so on. In that case, the inequality we're dealing with will be non-linear. It's not linear. Inequality versus equality. Equality, you must just see the equal sign. But the inequality, so equality, you must see just the equal sign by itself. The inequality, you must have either greater than, or less than, or greater than or equal, or less than or equal. In this lesson, we're dealing with inequalities, not equalities. So the object of this lesson, it will be how to solve nonlinear inequalities. Okay? Any questions so far? All right. Now there is a specific type of non-linear inequalities that we're going to study in this section. Polynomial inequalities. Because inequalities can be polynomial inequalities or quadratic inequalities or trigonometric inequalities, logarithmic, exponential. These are all nonlinear. But there's one specific type we are addressing today, which is polynomial inequalities. Okay? Now, how do we solve an inequality? There are 4 steps to solve any polynomial inequality, and I will explain these steps going over example A. I will explain these steps going over example A. The first step says express the inequality in the form of f of x less than 0 or less than or equal, or greater than 0, greater than equal to 0. So what do we mean by this? Look at this example, example 1a. So when we say we want this to be less than 0 or greater than 0, so what do I mean by that? Alice?
Put all the values on one side of the equation.
Very good. So put all the values on one side of the equation, and the other side of the equation will be what? 0. There you go. Here, what we have x squared minus x greater than 20. So what am I supposed to do here for step number 1? Subtract 20 from both sides. Okay? All right, so let's do that. This is gonna be x squared minus x. So when I subtract 20 on the left side, I will have what?
Minus one.
Minus 20. Greater than 0. So that's step number one. Step number one. Step number two says find the zeros of f of x. Why do we need to find the zeros in order for us to solve an inequality? Why do we need to find the zeros? Because we don't want to just remember that we have to do that. It will be easier to, it's okay to remember, but to understand as well. So if you have memorization and the understanding combined together, then that's going to be the most effective. Yes?
We gotta find out what values x can be.
Okay, so to find the zeros, you mean you find the x values for which this will be 0?
Yeah. for
Yeah, but
example.
why is that? What do I need that for? Why do I have to do that? Yes?
You have to know what makes the statement true.
Okay, so eventually at the end, we're gonna exactly what you said, like find out what makes this statement true. But there's something specific to the zeros, why we have to find the zeros. So let me take you maybe to an easier example to explain that, and then go back to this one. Sophie.
Because the answer is like an interval notation, which is like relating to the at.
Okay, so the final answer you want it to be the interval notation, but we need to find the zeros, and then how does that relate, the interval notation to the zeros? I see what you mean, because interval notation will be, let's say, going from -infinity to 2, 2 is a 0, either with parentheses or bracket, depending on which inequality we're dealing with, and so on. So let me go over a simpler example to explain why I have to find the zeros in order for us to be able to solve the inequality. So let's work with a very simple inequality, x minus 1 greater than 0. Solving this inequality would just require to add 1 on both sides. So you say x greater than 1, correct? But I don't want to do that. I don't want to do that. To explain why the zeros are important, I'm going to do something different. I'm going to draw a number line. And the number line goes from -infinity to +infinity. And then my question to you is, what makes x minus 1 equal 0? 1. Included or not included? Because, yeah, there is no equal, it's strictly greater than 0. Good. Now, if x equals 1, I'm going to get a 0. Now, my question to you is a 0 positive or negative? Yeah. So the 0 is not positive, it's not negative. That means the 0 splits between what and what? Okay, say it out loud. Positive and negative. If x equals 1, this is going to be 0. If x greater than 1, let's see. Let's choose a number greater than 1. Let's choose a 5. 5 minus 1, 4, positive. Let's choose a number smaller than 1, -5. -5 minus 1, negative. So what does 0 do? It splits between the pluses and minuses. Because if I have multiple of them, which happens with non-linear inequalities, multiple of them, then it's not going to be as simple as this. Then you would need the zeros, and the zeros, what they do, they split between the positives and negatives. Okay, it's the boundary. And that's how we can determine the values of x for which the inequality would be true, whether it's positive, negative, and so on. So far, any questions? No questions? Okay, so let's finish this example. So we said we need to find the zeros. Now, what type of, if if I change this to equation, what type of equation this would be? Quadratic. How many different methods we can use to solve a quadratic equation? 3 or 4. Okay, actually, in reality, it's 3. Because quadratic formula is a shortcut to what? Completing the square. When we have a chance, maybe we'll review that. So let's say 3. One of them is what? Factoring. That's actually our favorite. Second one? Third one? Graphing. Okay, good. So let's stick to factoring or quadratic formula if we need to. So how do we factor this?
X minus 5x plus 4.
All right, so two numbers, the product is -20, the sum is -1, -5 and 4, is that what you said?
Yeah.
Any questions so far? All right, so we factored. Now, what are our zeros? Because the reason we factored is to find the zeros. What are they? 5 and -4. So you want to put these numbers on a number line. -4 and then 5. Do we include the -4 and 5 or no? So we need an open circle, right? Why don't we include them? No equal sign. Good. Alright, so the number line goes from -infinity to +infinity and everything in between. So what do we do next? Let's look at so first step we're done, express inequality in the form of less than or greater than 0. Find the zeros, we did that. Plot the roots on the number line, we did that. Test the value on each interval. Test the value on each interval. So let's start with this interval over here. How do we do that? You remember how to test value? Amen. A little bit louder, please.
You pick a number that falls in that area.
Okay, can you give me an example?
Like, for which one?
For this one. 10. Okay, so we choose a number on this interval. Let's say 10. You can choose anything as long as it is what? Greater than 5. So let's choose a 10. 10 minus 5 is a positive or negative? And then 10 plus 4. So the product of two positives would be positive. When did we do this? When? When did we do this? When? Recently, not too long ago. To find what? The domain. Yes, I just gave you back the homework. The domain. Domain of what? Or the quiz, I think it was on the quiz as well. Domain of what? What kind of function where you have to use inequality? I mean, within the type of functions that we covered. So, domain of what kind of function you would have to use inequality? Alex?
Rational.
Rational. Not exactly. Rational doesn't need inequality, but maybe you're thinking of a mix of rational and something else. It doesn't have to be mixed, but I see what you're trying to say, right? You said?
I might be thinking of that.
Yeah, you're thinking of that. Yeah, that could be a combination of rational and what I'm looking for. I gave you back the homework in the quiz. Take it out right now and check and tell me.
Square root.
Radical. Yes, radical. Specifically, what index? What type of index? Or what kind of radical? So radical, that's general.
Square root.
Square root, right? Or the fourth root and so on. But we dealt only with square root. Because what's inside the square root has to be positive or 0. There you go. And then we did examples like this, where we had to solve the inequality. We're just going over it. Now again, however, in this section, we're gonna do different type of inequalities, not just linear and quadratic inequalities. We also gonna be going over rational inequalities, which we did not do in the domain, okay? Good, now let's test this interval. From -4 to 5, let's choose 0 maybe. 0 works, okay. 0 minus 5, negative, and then 0 plus 4 is positive, the product is negative. Alright, let's choose a number smaller than -4. And -5. Good, so -5 minus 5, that's a negative, and -5 plus 4, that's a negative. The product of two negatives is positive. Good. What are we looking here for? Pluses or minuses? Pluses. Why? Yes, because it's greater than 0. If I change this to less than 0, then what do we look for? Negatives. So in this case, positive. Do not assume that you need the positives just because it has to be positive. No. That's, that will depend on your inequality. It will depend on your inequality. So, who can give me the answer using interval notation?
Negative infinity, comma, -4.
Negative infinity, comma, -4,
And
parentheses.
union 5, infinity.
Good job. Any question on this, on the first problem? So what I want you to do now, there is something I want you to do. Okay? Take your TI-84, graphing calculator, and go ahead and graph x squared minus x minus 20. Graph it. And then I will put an approximate graph here, and then we can look at it. Graphically how it looks. Okay? Go ahead and do that. Then help me up to graph it. If you need help, raise your hand please with the graphing part. You should see something like this. Yeah, good. There you go. Yep. Just do y equals squared minus x minus 20. Okay, now go ahead and make that. Okay, this will give you one. You can do zoom out and it will fix it automatically. Zoom out. Can you see? Yep, good. Right. Sophie, okay? We just
Oh,
let's
yes.
just do zoom out 3, right? Okay, so you can see all of it. But I'm not looking for the exact values of this curve, but the overall graph, like the curve, how it looks like. Yes, that's good. Correct? Okay, correct. What happened? Invalid dimension? Which? Let's turn this off to fix the problem for you. Okay, so if you zoom out, so that will be better. View. Okay, that's good. Very good graph. I like that. Alexa. Let me help you a little bit fix the zoom. Okay. Do sorry, that's not so. Where's zoom here? Okay. Do Okay? Let's see what happened to the calculation. Oh. Okay. There's an inequality that, candidate was on. Good. Okay, same thing, do zoom 3, enter. Enter. Alright, so you wanna see the entire graph? Yeah, good. Amen. Do zoom 3, enter, we'll show you the bottom of the graph. Zoom 3, enter. Yeah, good. Good job. Good job. Okay, got it. So you have something similar to this, my graph. Okay? Now, if we were to solve it graphically, so how? If you were to solve this inequality graphically, looking at the graph, and the question says the inequality is greater than 0, which part of the graph will be positive? Which part of the graph will be negative? Which part of the graph will be 0? Tell me. Look at the graph. First of all, the values of the function will be the y values or the x values? The values of the function. The y values. Okay. Where on the graph the y values are positive?
Above 0.
Can you say it loud, please?
Above, well, obviously above 0 if they're positive, but.
So anything above the x-axis, the y values will be positive,
Yes.
right? And anything below the x-axis, the y values will be negative. So if we are solving an inequality that is greater than 0, that means we're looking for whatever is above the x-axis. And that, for what x values, reading from the graph, for what x values are the y values of the graph greater than 0? Yes?
When x is less than -4 and greater than 5.
Exactly. When x is less than -4 and when x is greater than 5. And that's exactly what we said over here. From -infinity to -4, from 5 to infinity. And the zeros are the x-intercepts. Any questions so far? So I want you to have an idea about the graph, because later when we encounter a case where the polynomial has no zeros, no real zeros, then we want to make sure we understand whether this is going to be always positive or negative, or we have no idea. So we'll see. So now, to test your knowledge, I'm going to go ahead and have you solve example B. If you need help, I'm going to walk around, and if you need help on how to, after the first step, how to find the zeros, raise your hand, and I can help you, but I'm going to be going around. Yes? I'm sorry? Oh, you need help already. Good. Yeah, good. So, do the first step. Yes? Yeah, I'll be there. Sure. So the first step, let's just do at least the first step to make sure everybody is on the same page. What's the first step? Yes. So x cubed plus 3x squared. Can you finish it?
Minus x minus 3.
Say it loud, please.
Minus x minus 3 is less than 3.
Okay, good. All right, go on now. From here, try to find the zeros, then we go from there. Ahimed, you raise your hand, so let me check. What do you need? So, factor by grouping. Factor this group, factor that group. So, you know, factor by grouping, so you divide this into 2 groups. Factor the first one. There you go. Yes. Good, so keep going. Need help, guys, or okay? Yeah, this is correct, what you did is correct. Mason? Yes, I think so. Yeah, so recommendation to you is, okay, keep writing the inequality, you also wanna factor that.
Okay.
So it will be, this is difference of two squares, so factors two. And the other one? X minus one times? X plus one, good, so write the whole thing and then test the values, okay? Still. Good, keep going. Okay, so you're missing one value here. So -1, yeah, -3, -1, and +1, so you have more than one interval to check. See now? You can also factor this, will be x plus 1 times x minus 1 times x plus 3. Pretty easy that way, okay? X minus 1 times x plus 1 times x plus 3. Squared minus 1, so if you factor this, will be easier. X minus 1 times, here, you see here? Not yet completely factored. First of all, you do x plus 3 times x squared minus 1. Then the x squared minus 1 factors to x minus 1 times x plus 1. Then you test the values. Is that clear? Okay. Yes.
When I test this, where do I test that?
So, you did not factor completely. First of all, keep writing less than or equal 0. Go ahead, write less than or equal 0. Alright, now the next step would be x plus 3 times x squared minus 1. I think you need to erase that. The way you're solving it is going to be a little bit difficult. You can do it that way, but it requires a lot more work.
So should I erase everything?
It is this. Okay, so now you have x plus 3 times x squared minus 1. Write it down. X plus 3, this is common factor,
Yeah.
times x squared minus 1. You need to factor completely. So now, keep writing the inequality. Now erase this too as well. And this one. Erase everything, yeah. Okay, now factor x squared minus 1. X minus 1 times x plus 1, and then x plus 3. Now go ahead and test the values, okay? Yes, it is. Okay. Sophie, can see what you're doing? Oh, you're done. Okay, good job. That's correct. Very good. Good job. Yeah, something extra in here. This one is extra. Check it. Yeah, check it again. Yeah, this is plus, and you're taking the minus. Took the minus. Yeah, check again. See what's going on, Connor. Where is your factor? First, you need to have a factor, which according to your work, you should have x plus 3 times x squared minus 1. Oh, using a pen is gonna be tough, because you can't erase now. Using a pencil is better, but you should have, you should have x plus 3 times x squared minus 1. And then you test values, okay? That's good. Is it greater than or equal? Is it less than? Okay, so it's fine, you can change all this to less than or equal. The final answer is correct still. So, because you put the minuses. No. Okay, change the inequalities and then change your final answer. Awesome. Okay, so far so good, I like that. That's good. Okay, keep going. That's good. Michelle? Yeah, it looks correct, yes. Good. Good job.
Thank you,
About,
that's very important. Go further.
Yeah, so, keep writing inequality. You put,
Yeah.
less than or equal 0, next one will be x minus 1 times x plus 1 times x plus 3. And then have tested using the values. Yeah, like both. This is correct. So test values, final answer, that's good. I think we're including the zeros, right? Excuse the equals. Yeah. About Lucy. Keep the x plus 3 here, doesn't equal 0. Okay. I don't know what that is, but
Oh, yeah, it was just.
yeah, it's put the times x plus 3 doesn't equal 0, then you test the values. Okay? So here. Okay. Yeah, all right, so I'm gonna go ahead and go over it. A lot of you got the correct answer, and let me make sure that everybody knows how to solve this inequality. So first of all, we said we're gonna factor. Because we have 4 terms, then we have to use the factor by grouping method, okay? These are the 2 groups. First group, second group. What's the common factor of x cubed plus 3x squared?
X squared.
So x squared. Good, so x squared times x plus 3. And then, what's the common factor between negative x and minus 3?
-1.
Yeah, -1, good. So that's why -1 times x plus 3 less than or equal 0. Now, what is the greatest common factor between these 2 terms? X plus 3. See, x plus 3 in the first term and x plus 3 in the second term. So we got x plus 3 as a common factor. And then what goes in the second binomial? X squared minus 1. Good. Now, I saw some of you using the square root property to solve this, which is fine as long as you know what you're doing, is fine. It would be easier actually if you just factor everything. So it's going to be x plus 3, or factor completely. X squared minus 1 factors 2. X minus 1 times x plus 1. Good. Now we're ready for the what? Number line. We're ready for a number line. So number line goes from negative infinity to positive infinity. And then the zeros are what?
-3, +1, and -1.
Good. So -3 and -1 and then +1. Make sure you have the correct sequence. So the smallest and then next smaller than the plus values. All right, so do we include the zeros or not?
Include.
We include. Because?
There's an equal sign with them.
Because there is the equal sign over here. The equal sign will signify that we must include the zeros, these values. Okay, so we now, those values will be part of the answer. Maybe not all of them will see, okay? Actually, sorry, all of them, I'll take that back. All the zeros will be part of the answer. Why? Because it says less than or equal to 0. So equal to 0 are -3 and -1 and 1, so we must include all of them. Now, we need to check the intervals. Let's choose a number greater than 1. 2, okay. 2 plus 3 is positive. Yeah, 5 is positive. 2 minus 1 is positive, and 2 plus 1 is, so that's positive. There is a shortcut to this. Once you know the sign of one interval, as long as you have no multiplicities, meaning none of the zeros repeats. None of the zeros here repeats. -1, 1 time. 1, 1 time. -3, 1 time. So this is going to be plus, minus. But if any of the zeros repeat, then no. If let's say 1 repeats, let's say I put square over here, I'm going to remove it, okay? Then it means the 1 has even multiplicity. We learned this in the last section, even multiplicity. Then, if to the right is positive, to the left is also positive. But if we're not comfortable using that shortcut, then what we have to do is test every single interval, okay? So in that case, we have to check the next interval. Let's choose a number between -1 and 1. 0. 0 plus 3? Positive. 0 minus 1? and 0 plus 1, positive. So it looks like we have two positives and negative, that will be a negative. So plus, minus, let's keep on going. Go a little faster on this one. Let's choose a number between -3 and -1. -2. -2 plus 3 is positive, -2 minus 1, and -2 plus 1. So the product, as you can see, plus, minus, plus, this is going to be minus, so just put a minus there. Okay, you can test it, choose a value, test it, it will be a minus. Now, who can use interval notation to write the solution? Or, before we do that, are we looking for minuses or pluses? Because?
Less.
Yeah, because it says less than. Okay, less than. So we want minuses. So the first minus will be over here. And the second minus. So it's obvious which intervals must be included in the solution. Can anyone tell me what the solution is using interval notation? Can you say it loud, please?
Parentheses, negative infinity, comma, -3, bracket, union, bracket, 1, comma, infinity. Oh,
You mean-
1, comma.
That might be good. Great. Is this correct?
Yeah.
So why brackets, not parentheses?
Zeros.
Yeah, because we have to include the zeros. Okay? So please go ahead and work on the next example, which is example C. Try it, see what you can do, and then we'll go over it, okay?